Hello, hello, hello. CheersKevin here, and welcome back to some more EXAPUNKS, where we are clipping along. I think this is the final of a very long series of of marathon videos that I'm recording kind of all in one session because, man, this game is exciting. How many receipts do you think a normal human being could enter per minute, assuming average conditions? One. Oops, my estimates were based on incorrect assumptions. Once again, guess we have to clear this up. Okay, so somebody was going through the workhouse, which was the Mechanical Turk Amazon clone, and perhaps doing a little bit more. Locate Ember 2 users file, but the users file override it so the sum of values is the same, but no individual value exceeds $75. Oh man. Okay. All values except for the last must be the maximum value. You will need to add additional values to accomplish this. Ember 2's username is available in file 300, which we can see it is normal human. So that's a great name. The sum will always be less than 10,000 USD. So, user's host, which contains a file for each account. Yep, as we surmised. The file has a username, date of birth, and log of how much money the user earned that day. Okay, so we're not going to change that. The total needs to be the same, but whatever. Okay, job database. Then there's a jobs host, which contains information about the current active jobs, and task database. Okay, I'm sorry, I misread it. Okay, so basically we just need to then open this file, keep, I guess, these things the same, but then write additional value. So $75, $75, $75, $75, and then whatever the remainder is once we're at less than 75. Okay, that's easily doable. This seems fairly straightforward. Okay, so we're going to grab file 300. We'll copy F into our X register, wipe the file, and jump into 800. Oh, no, we can't wipe the file just yet. All right, yeah, no, that's fine. Yeah, we'll grab file 199. Then we will, we need to read until we find normal human. So we'll say mark loop, and we will say, test if file equals X, and false jump to loop. Then once we're done with that, we will jump ahead by one more because this is the birthday, or the password, I guess, which we don't care about. So we'll seek forward by one further, and then we'll copy F into X and then drop the file. Then we will go ahead into 799, and then we need to grab, and I guess we can just grab X, and it will know that that means that file name. Then we need to, let's create a note, take a sum. So we've grabbed the file. We're going to seek by 2, and then mark sum. Let's see. Do we have X? Have we used up X? I'm not sure. Do we need to set X to 0? Maybe. Add X, F, X. Oh, whoops. Add integer, and then jump to sum. We'll move on to that. We'll move on to that next step. Okay. So we're searching through to find normal human. We find normal human. We jump ahead by 1. We copy that file name. We go in here. We grab that file. Good. And X still has the value. Okay, so we need to clear out X. Or better, what we could do is just copy F into X. And yeah, that should work just fine. So we need to also test if we're at the end of file, and then just jump if false. So false jump to sum. And once we're done with that, that should mean that we are golden. You will need to add additional values. And yeah, we know for certain that we're going to be adding more 75 entries. So we don't need to worry about, are there going to be some things that we need to clear out? Okay, so we've figured out the sum. Now all we have to do is overwrite the data with 75s until we have less than 75 in X remaining. So we'll seek to -9999. We'll seek forward by 2, and then we'll say mark fakes, and we'll say copy 75 into file, and that's going to advance the file head, but we've already handle that well. And then we'll say sub I x subtract 75, put that into x, and then we'll say test x is less than 75, false jump, go back to fakes, false jump, false JMP, go back into fakes. So continue putting in 75s. Once we're done, we will copy x into f, and then drop, and then halt. Right? That sounds reasonable. Let's see if that works. 75, 75. We're adding all of these 75s until we have, until this counts down to there. And that works. Perfect. Not perfect. There is one case. Aha. Okay. Yeah, if we have 0 remaining, we need to handle that case. Fine. We'll just mark done. And I feel like there's a cleaner way to do this, but whatever. We'll just test x equals 0. And if so, true jump to done. And that should work. There we go. Alrighty. Not too many cycles, decent on size and decent on activity. Let's return to the desktop. Just when I think I'm decent at pretending to be a human, I find that there's another parameter to add. How long have you pretended to be human? Oh, pretty much from the start. It's kind of a thing that I do. Remember when I surprised you? That was a good one. Let's continue. All right. That one is done. Oh, how's the war dialer? All right. Equity First Bank. Cause multiple automatic teller machines to spit out cash. How much does money affect behavior? A lot, right? Some money behaviors aren't affected by money. I'm going to do an experiment involving wealth redistribution. Sudden random wealth redistribution. This should be fun. Ooh, green and money-like. Okay. More information, view, network exploration, equity. First, in the first issue of the zine, we need to dispense all available cash from all connected ATMs. Interesting. All right, Equity First Bank. Account files. We don't care about account files as far as I know. ATMs. You'll see a number of ATMs connected over dial-up connections. The first only dispense $20 bills, so cash register tells you how many bills are remaining as opposed to how much money is remaining. If you write 20 to the disp register, it will attempt to dispense a bill, but if the ATM is out of bills, it'll send a failure message that alerts the bank. Okay, so yeah, there are a lot of variants of this problem. We don't care about these files. What we're gonna first do is just worry about the linking. So we'll link into 800, link into 800, and yeah, one more 800. And here we're at the point where we can do cloning. So actually, I want to test something real quick. I'm gonna say copy. Let's create a label. So we'll say mark start. Copy 5 into X, and then we'll say REPL start. Let's say no op multiple times so we can just easily watch this. All right, so do nothing, copy 5 into X, and then start. And now this clone one, okay, it does already have X in its register. That's what I was trying to check. Okay, I'm just gonna worry about assuming we're already here. Yeah, so we'll say, okay. So link to 800, link to 800, link to 800. Now we're going to say copy 800 into X, and then 6 times we are going to mark dispenser. We will REPL dispenser. So mark loop, REPL dispenser, add I x1, store that in X, and then we'll say test X is greater than 806. Yeah, and if that's not true, then we will, so false jump back to the loop, and then go ahead and halt. So we're just going to create 6 dispensers, or sorry, 7. Yeah, 7 dispensers. And now the dispenser logic should be pretty straightforward. We're just going to link to whatever's in our X register. Then we've got to grab we've got to get a count from cash. So we'll copy cash into X, and then we will mark moolah. I don't know, give it some label. Let's see. I suppose it is possible that we could get burned if there are 0 bills. Yeah, I suppose let's test that. Test X equals 0. true jump to done. Mark done. Done is just going to be halt. Otherwise, we can go ahead and dispense. So let's send. Oh, and actually, we don't need jumping at all. We can just multiply this by 20, right? And then just write 20 times this, I think. No, okay. So we do need to distribute things in $20 denomination. So we do need the loop here. Okay, so fair enough. Then we can just copy cash into, multi cash times 20 and put that into X. And then link X, mark moolah. We'll say if X equals 0, test X equals 0, and true jump to done. Otherwise, copy 20 to disp and subtract sub I x20 x and jump to moolah. All right, so if we run this, it jumps in there, it slowly starts ticking away, and we start ticking away on all of these, and they're all slowly draining. The question is it going to work once we get to the end? No, we ended up with an error. Oh, so wait, X, somehow you're in a bad way. Why are you in a bad way? Yeah, but that's going to be a problem because you're going to throw more stuff at dispense and then they're going to get alerted. Instead of, we don't even need to multiply. Since we're just copying 20 anyway, we don't need to multiply. We can just copy cash into X. Actually, we don't even need to use X, do we? We can read it directly. Let's do this. Dispenser. We'll just say test cash equals 0. And if so, done. Otherwise, do this. And we don't need any of this. Jump to dispenser. Yeah, making that way too complicated. There was no reason to even throw it into a temporary register. What did we do? Oh, whoops. Managed to remove a line, it seems. Jump into X. Oops. Yes. Jump into the X register. Let's try that. Oh, sorry. Not jump. Link into X. All right. Link ID not found. Oh! Okay, fine. Mark moolah and jump to moolah. All right, there we go. So people were able to do it in significantly fewer cycles. I'm curious as to how, but we seem pretty middle of the road there. And cool. Well, that caused a bit of chaos, but not as much as I had hoped. I wonder why. People are good at ignoring problems. I'll have to aim for something bigger next time. Alrighty. Hack your heart. That sounds like a good way to end this episode. Hack your heart so it continues to beat properly. So you're going to be hacking your own heart. It'll be fine, probably. Good. What happens if your heart stops beating? Don't tell me. You die? Processing. I guess that explains some things. At least all you need to do is make it beat. It's a little more complicated than that. It's fascinating. I should learn more about it. Okay, so read a value from the nerve connected to your central nervous system. So here, make your heart beat by writing a sequence of values to your sinoatrial and atrioventricular nodes as indicated in HDI 10 IO log when holding the show goal button. Okay. So there's that. That's not hugely enlightening, but okay. The length of each sequence of values should be equal to the value from the CNS divided by -10. Repeat ad infinitum. It is not necessary to leave no trace. So, okay. So we're going to have a reader and 2 writers. And the output here is, writing a sequence of values. How do we even where do we even get this 40 out from? I guess we're kind of deriving that? I guess? Is that true everywhere? Yeah, okay, so fair enough. While there is a number, okay. So interesting, if you'll notice the SAN and the AVN, they both get this 40 value at different times. Okay, so basically they're outputting -70, except when they get an input, and then they output 40. Fair enough, and we don't care what the value is. Is that true here as well? Yeah, does seem to be. Okay, so it's just -70 and 40. So we'll just go copy nerve into M, and we're gonna do that. We're gonna have to copy nerve into X, and then copy X into M, and copy X into M, because we need to send it twice. I don't like this because we've got two things that need to listen to the same thing, which, okay, that's fine. Yeah, we'll just copy nerve into M, and we'll just have to work out the timings, I guess. No, we can't work out the timings. Well, we'll see. All right, so you, SA, let's see, which one needs to get the signal first? Okay, so SAN needs to get it first. So 800, link you to 800, link you to 1, link you to 1, equal to the value from the CNS divided by... okay. Fair enough. Length of each sequence of values is equal to the value from the CNS divided by -10. So the value, it does matter. And hello, Future Kevin here, taking a look at this solution and just how messy it is. I think this is one that we'll revisit in the next video, just because, man, I overcomplicated things by trying to worry about blocking communication, when in reality, we have a way to check whether there is something in the M register without blocking, without consuming it. We have the ability to test for that. So really, we should do that, and it would make this whole thing a lot cleaner. We did end up with a solution that works, but as you'll see, it ended up pretty ridiculously complex and involved a bunch of no-op timing. So we'll go ahead and just kind of gloss over that for now and revisit this problem in a future video. Yeah, there we go. Okay, so this is more complicated than it needed to be. But hey, we figured out the timings. And yeah, the issue is just we were flooding things through too fast, and yeah, okay. Do you ever wish you were a computer? A functioning computer, I mean? Nah, that's okay. I never wish for a human body myself, but they're so interesting to learn about. Such strange design choices. Alrighty, is there something for us to say? No. Alright, replace the words in the message sent to gas to change its meaning. Let's take a look and at least see what it is. Well, this is flattering. Someone found a bunch of network nodes and sent in a tip to gas. Too bad I can't have people knowing about me. You're going to have to hack me out of that message. Are you spying on Gast? I live on computer networks. Sometimes I see things go by, that's all. Digicam feed, there is Gast, hanging out, being cool. All right, find and replace the keywords in the target message as directed by Ember 2. Okay, a list of keyword pairs indicate which words should be found and what they should be replaced with is available in file 300. Each keyword only occurs once, but it may occur in any order. Also move file 200 to the outbox. Okay. I think this is another case of using the excuse me, another case of using the global register. So we need to replace this in 212 and 200 to the outbox. Okay. So A, you're just gonna grab, what is even in file 200? Oh, just move this file to the outbox. Sure, why not? Yeah, so let's grab 300. And then we're gonna do some stuff. Let's see. Test EOF. Let's see. Mark reading. Test EOF. And false jump to reading. We need to actually do the reading here. Say copy F to the big register. False jump to reading. Then when we're done with all of that, we'll wipe that and then grab 200 and link 800. Oh, I suppose we need to, yeah, we need to link 800. Well, nah, we don't. Yeah, we're good. And halt. We'll create another one who's very dumb. All it does is link 800 and grab 200 and link 800 and drop and halt. So that one's all it's going to do is take this file and move it over there, move it into the outbox. And then C is going to go into gas system. So we're going to link 800 We're going to link 799, and then we're going to grab 212. And now we've got kind of a slew of messages coming in through M. We will see mark, replace. Okay, so there is actually a test MRD, which is a test if we are able to read without getting stuck, and that'll be an easy way for us to determine when we are done. There was one example where I sent a -1 as a signal that we were done, but this actually seems smarter. So MRD, if there's nothing to be read, then we need to true jump to done. And so let's mark done, and we'll say drop and halt. Okay, the other ones, so basically then we're just replacing word pairs. So let's copy M into X, and okay, so the process of just replacing one pair is what we have to write inside here, and then we'll loop jump to replace. So seek to -999, go to the beginning of the file, and then copy that, and now we need to find the word, which means that we need to say test f equals x, and false jump to find. So we got to mark find. Find. Then f equals x. Hooray. And now we need to replace, which is just copy x over into f, although we may need to do a seek backwards. Let's walk through that just to double check. Oh, no, not copy x into f. Copy m into f. Though we may need to seek backwards by 1. I'm not positive. Let's watch this one go. Okay. Well, where did these all go? Okay, hang on a second. XC. Why are you done? Why did you end up being done? Something told you to true jump. Oh, right. I'm sorry. False jump. Yeah, if there's nothing for us to read, then we need to jump to done. Okay. So we're in replace. We are copying. Okay, so AI is the word that we're searching for. And is this it? Is this it? No. All right. A rumor about the AI. Okay, so it's going to replace that. So we do need to add a seek to -1. And there we go. I think we should be done. No, we're not quite done. Oh. XA is still... Aha, okay, so it just so happens that this jump is a little too fast. So, yeah, we actually need to wait by just 1 when we're testing to see if there's something for us to read. So, fair enough. We'll add a no-op. We could also send an end of signal type of thing. Which, I mean, would be faster. Let's probably, yeah, let's do that. Yeah. We'll go ahead, we'll copy M into X. We'll say test M equals -1. Or, sorry, X equals -1. And true jump, then go to done. At the end here, once we're done reading, then we will copy -1 into M to let it know that we're done. So we're just using that as sort of an end of file statement. That means, okay, so if we jump through, we get AI. It means we should still wait to get that value. So we got AI. We've done our replacement, and now we're going to wait until it has a chance to copy that word that we're looking for. And now we know that we're looking for network. Okay, so that gets forwarded along, and there we go. So it's trying to find network. It's trying to find information. Okay, perfect. So minimal cycles, not too bad on size, not too bad on activity. I think, well, see, you didn't look at any other files while you were in there, did you? I might have. Oops, maybe don't tell him you accidentally saw some of his private files. No reason to upset him. He needs to focus on the issues of the zine anyway. All right, meeting with gas. aghast. Let's take a look at this last thing.
Hey, I have some things for you.
Oh, yeah?
First off, we got the next zine.
All
Hot
right.
off the press.
I'm excited. Gas hands me the next issue of his zine.
Help me out.
Interesting.
I had a balance at the copy shop, but someone hacked it.
Nice.
Speaking of which, I brought you something else.
Gas holds up what looks like a handheld game console. I do not.
People say this thing was underpowered and just a gimmick, but it has its charms.
It does.
This is the developer version, so you could make something with it if you wanted. The game studio I worked for never took it back after I quit. I'll be happy knowing it's going to a good home.
I appreciate that.
More zines now.
All
I'll
right.
catch you later.
Have a good one. And there we go. Trash World News number 2. Hackverse, lots more stuff. Letter from the editor, building momentum, lots of stuff. So we're going to end up doing a lot more things. And it looks like, some audio systems and stuff. Things to do with that gaming console that was mentioned. All right. I am excited to delve into, I guess, the second chapter of this game. But that will have to take place in a future episode. So until then, I hope you have a good one. And I will see you soon. Cheers.